Can a magnet create electricity? Have you ever wondered if a magnet can actually create electricity? It sounds like magic, but there is a fascinating science behind it. Let's break it down in simple terms. First off, a magnet alone cannot create electricity. It needs to work with something called a conductor, which is often a coil of wire. The magic happens when there is movement involved. This is based on a principle known as electromagnetic induction, discovered by Michael Faraday in the 1820s. So, how does this work? A magnet produces a magnetic field, which is an invisible force that extends from its north pole to its south pole. Conductors, like copper wires, have electrons that can move around freely. For electricity to be generated, either the magnet must move near the conductor, or the conductor must move within the magnetic field. This movement changes what we call the magnetic flux, which is the amount of magnetic field passing through the conductor. When the magnetic flux changes, it induces a voltage in the conductor. This is known as electromotive force. The faster the change in the magnetic field, the higher the voltage produced. If the conductor is part of a closed circuit, this induced voltage causes electrons to flow, and that is how electricity is created. This principle is the foundation of how generators work. In power plants, large coils of wire are rotated within magnetic fields, or magnets are rotated near coils. This process converts mechanical energy into electrical energy. It's important to note that the magnet itself does not create energy. It simply converts motion into electricity. In everyday life, you can see this principle in action. For example, if you move a magnet through a coil of wire or spin a coil in a magnetic field, you can produce electricity. This relationship between magnetism and electricity is a key part of electromagnetism, which also explains how electric motors and transformers operate. So, to answer the question, a magnet cannot create electricity by itself. However, when it is combined with motion relative to a conductor, it can induce an electric current. This interaction is fundamental to much of the electrical technology we use today.